Time you're at an airport, stop and look out across the tarmac. Dozens of aircraft lined up, gleaming under the sun, and almost every single one of them is white. Not silver, not gray, not the airline's brand colors, white. You'd think airlines would want their planes to stand out. You'd think bold colors would be great for marketing. So why does almost the entire aviation industry default to the same plain, simple color? The answer involves physics, money, safety, and one of the most fascinating engineering decisions in the history of modern travel. Let's break it all down. Airplanes are among the most expensive, most complex, and most carefully engineered machines ever built. A single commercial aircraft can cost anywhere from $80 million to over $400 million. Airlines operate on notoriously thin profit margins, sometimes as little as 2 to 5%. That means every decision made about that aircraft, from its fuel load to its seat configuration to the paint on its fuselage, gets scrutinized down to the last cent. So when the entire industry lands on the same answer for paint color, you can be sure there are very good reasons behind it. And as we're about to find out, those reasons go much deeper than you might expect. Let's start with physics, because this is where the story really begins. When sunlight hits a surface, one of two things happens. The light is either absorbed as heat or reflected away. Dark colors absorb more light and convert it into heat. Light colors, especially white, reflect the majority of sunlight back into the atmosphere. Now think about where an airplane spends most of its life. Parked on a sun-baked tarmac for hours, flying at high altitude where UV radiation is significantly stronger than at ground level, sitting in tropical airports where ground temperatures can exceed 40 degrees Celsius in direct sunlight. A dark-colored airplane sitting on the tarmac on a hot day can get significantly hotter inside than a white one. And that heat isn't just uncomfortable for passengers, it has serious engineering consequences. The interior components, wiring, seating materials, overhead bins, insulation, are all rated for specific temperature ranges. Excessive heat accelerates wear, weakens materials over time, and adds to the overall fatigue of the aircraft structure. White paint is, in a very real sense, a passive cooling system. It keeps the aircraft cooler without burning a single drop of extra fuel. Here's something that will genuinely surprise you. The paint on a commercial airplane weighs between 200 and 600 kilograms. That's the weight of several adult passengers just sitting on the outside of the aircraft doing nothing but looking pretty. In aviation, weight is everything. Every extra kilogram requires more fuel to lift, and more fuel burned means more money spent and more emissions released. Airlines are obsessive about weight reduction. They've experimented with lighter seats, thinner windows, even lighter trolleys for the cabin crew. So paint weight is absolutely a factor that gets analyzed. Now here's where white has a direct advantage. White paint typically requires fewer coats to achieve full, even coverage compared to darker or more vibrant colors. A deep red or navy blue might need additional layers to achieve the rich, uniform look an airline's brand team is after. More coats mean more weight. White, on the other hand, can often be applied in a single full coverage coat, keeping the total paint weight as low as possible. Some airlines have gone even further, experimenting with bare metal sheen or unpainted sections of fuselage to eliminate paint weight entirely. But even those aircraft tend to use white for the majority of the surface, simply because of how well it performs. Now we get to one of the most compelling reasons of all, and it has nothing to do with fuel or temperature. It has to do with safety. Every commercial aircraft goes through rigorous, regular maintenance inspections. Engineers examine the entire surface of the fuselage, looking for cracks, dents, corrosion, oil leaks, hydraulic fluid seepage, or any sign of structural damage. And here is where white paint becomes a genuinely powerful safety tool. Cracks, fractures, and surface damage show up dramatically well against a white background. A hairline crack on a white surface can be spotted by a trained inspector from several meters away. That same crack on a dark blue or black surface, it could be nearly invisible until it's dangerously large. Oil and fuel stains, which can indicate a leak somewhere in the system, appear as dark discoloration against white paint, immediately drawing the eye to a potential problem. Aviation safety has always been built on the principle of catching small problems before they become catastrophic. White paint is part of that system. It makes the aircraft easier to inspect, and easier to inspect means safer to fly. Airlines don't just buy aircraft, they sell them, lease them, and trade them between carriers constantly. A plane might operate for Singapore Airlines for 10 years, then get repainted and transferred to a low-cost carrier in Europe, then leased to a regional airline in South America. The
the aviation industry runs on an enormous secondary market for used aircraft, and here is where white paint turns out to be an extraordinary financial decision. A white aircraft is essentially a blank canvas. When an airline acquires a second-hand aircraft painted in another carrier's livery, say a bold red and yellow scheme, the first thing they have to do is strip or paint over that livery before they can apply their own. Stripping paint is expensive, time-consuming, and adds to the aircraft's downtime, which is money lost every day it isn't flying. A white aircraft is far easier and cheaper to repaint. You're not battling an existing dark base coat. You simply apply your livery markings on top of the white. This dramatically reduces the cost and time involved in transitioning an aircraft between operators, making white-bodied planes significantly more attractive on the resale and leasing market. Over the decades, this financial reality has pushed the entire industry towards white as the dominant base color. There's another factor that rarely gets talked about: how paint ages. Commercial aircraft are in service for 20 to 30 years. Over that time, they're exposed to extreme UV radiation, temperature swings from -60°C at cruising altitude to blistering heat on tropical runways, high humidity, ice, rain, and constant mechanical vibration. Under these conditions, colored paints, especially deeper hues, fade dramatically. A vibrant red livery that looks stunning on a brand new aircraft can look washed out, streaky, and unprofessional just a few years into service if it's not regularly maintained. White, by contrast, doesn't fade in the same visually dramatic way. A white aircraft that's 5 years old looks remarkably similar to a white aircraft that's 2 months old. Airlines don't need to repaint white fuselages nearly as often to maintain a polished, professional appearance. And repainting an aircraft is not a small task. It can take up to 2 weeks and cost hundreds of thousands of dollars. The fact that white ages gracefully and requires less frequent repainting is another powerful argument in its favor. Of course, white isn't universal. Some airlines have deliberately gone against convention, and the results are fascinating. Condor Airlines of Germany made headlines when they painted their fleet in bold, candy-colored stripes: pink, yellow, blue, and green. It became an instant talking point and a massive branding success. Aeromexico has used deep navy schemes. Some carriers use all-black aircraft for special edition liveries or rebranding moments, and several airlines have experimented with tail-to-nose color wraps for marketing campaigns. These bold choices make a statement, but they come at a cost. Airlines that go heavy on dark or vivid colors tend to repaint more frequently, spend more on paint maintenance, and deal with faster fading liveries. They're making a deliberate trade-off, paying more to stand out in a crowded market. For most airlines operating hundreds of aircraft, that trade-off simply doesn't make financial sense at scale. But for a smaller carrier trying to build a distinctive brand identity, it can be a very smart move. The aviation industry is now looking at something that could change aircraft appearance entirely, and it goes beyond color choices. Engineers are currently developing and testing smart paint technologies. One area of research involves thermochromic coatings, paints that actually change color in response to temperature changes, which could give ground crews a visual indicator of heat stress on specific areas of the fuselage. Another emerging technology involves electroluminescent panels that could allow airlines to completely change their livery digitally, the same way a screen changes an image without ever touching a paintbrush. Imagine an aircraft that displays one airline's branding in the morning and a completely different livery by the afternoon, purely through electronic switching. We're also seeing serious investment in paint-free fuselage designs, using composite materials and surface treatments that maintain the same protective and reflective properties as white paint without the weight or maintenance cost. Airbus and Boeing are both exploring these directions. The age of paint as we know it may eventually end, but for now, the humble white coat remains the smartest solution the industry has found. So there it is. What looks like a simple, unremarkable color choice turns out to be one of the most rational, multi-layered engineering decisions in modern aviation. White reflects heat and protects the aircraft structure. It keeps weight low by requiring fewer coats. It makes safety inspections easier, helping engineers spot cracks and leaks before they become serious. It ages better than darker colors, reducing the frequency and cost of repainting. And it makes aircraft more valuable on the secondary market, giving airlines financial flexibility across decades of operation. Every single white airplane you see taxiing down a runway is the result of engineers, accountants, safety experts, and fleet managers all arriving at the same conclusion. This is the smartest choice. The next time you board a flight and walk past that plain white fuselage, you'll know you're looking at a decision that is anything but plain. If you enjoyed this video, give it a like and hit subscribe, because every week we take something you've seen your entire life and reveal exactly why it works the way it does. See you in the next one.